Hi, welcome to Amigos Code. My name is Nelson, and in this video, I'm going to teach you about Docker. Docker allows you to package up your applications into containers. And the cool thing about it is that whatever you test locally, it is guaranteed to work within the testing environment, development environment, or even production environment. Docker is widely used amongst tech companies nowadays, and it is the standard. So without further ado, let's go ahead and learn about this awesome technology. All right, let's go ahead and understand what exactly is Docker. So Docker is a tool for running application in an isolated environment. So it's very similar to a virtual machine, but it's much faster and doesn't require a lot of memory and an entire operating system to operate. The cool thing about Docker is that your app runs in the exact same environment. If it works on my machine, it will definitely work on your machine. If it works on the staging environment, it will also work in the production environment. So this is one of the benefits of Docker. And pretty much it just works, right? If it works on my machine, then you are guaranteed that whatever you deploy your application, it will also work. And Docker nowadays is the standard for software deployment. Pretty much everyone is adopting Docker in their workflow for software deployment because it makes it easier for packaging applications. You don't have to deal with different OS, different distributions, and pretty much whatever you package will work in production. So pretty much almost every company is adopting Docker, and you should be aware of how to use this tool as well. So what exactly is the difference between containers and virtual machines? So a container is an abstraction at the app layer that packages your code and dependencies together. Multiple containers can run on the same machine and share the OS kernel with other containers, and each running as an isolated process in user space. So this is very important because a container doesn't require a full operating system, and it simply shares the underlying operating system but running in isolation of other containers. In contrast with virtual machines, is an abstraction of physical hardware turning one server into many servers. The hypervisor allows multiple VMs to run on a single machine. Each includes a full copy of an operating system. This is very important, a full copy of an operating system. Also, the application, necessary binaries and libraries taking up tens of gigabytes. And also they are very slow to boot. So just let me show you exactly a visual diagram. So this is a containerized application. So you can see that you have multiple apps. Underneath you have Docker and nothing else. So Docker manages all of the containers that you spin up. And underneath Docker you have the host operating system, and then you have the actual infrastructure. In contrast with a virtual machine, you can see that you have the infrastructure. On top of that, you have the hypervisor, and this allows one server to be turned into multiple servers. And you can see that each virtual machine requires a full guest operating system. So this is the fundamental difference between Docker and virtual machines. So the benefits of using Docker is that you can run a container in seconds instead of minutes. As you see that for you to spin up a full operating system, it takes a while. Also, less resources results in less disk space as well as less memory. So these are very good advantages of using Docker instead of virtual machine. And as I mentioned, you don't need a full operating system. So these are some of the advantages of using Docker, but obviously you have things such as deployment and testing. So you can test things locally and then you can take it to whatever environment, and it is absolutely guaranteed to work. If you have any questions, go ahead and drop me a message. Otherwise, let's move on and learn how to install Docker. All right, let's go ahead and learn exactly how to download and install Docker. Navigate to docs.docker.com/install. So right here, you can see that you can download Docker for Linux, Mac OS, and Windows. So the process is the exact same thing whether you are on Windows or Mac. So because I'm on a Mac, let me go ahead and show you exactly how to get it for Mac. But for Windows, it's the exact same thing. I'm going to show you in a second. So go ahead and click on Mac OS. And then you can see that to download Docker for Mac, head to docker.hub. So what I'm going to do is press Command and click on the link. And then right here, you can see that I can get started with Docker. So what I need to do first, so to download Docker desktop, so this is what we need, is to pretty much create an account or sign in. And once you have the account, you will be able to install Docker. The process is very straightforward. So you can see the requirements. So Mac OS Sierra 10.12 or above. So if you are using a previous version, you need to download Docker Toolbox. So Docker Toolbox is the old way of using Docker, and Docker Desktop is the newest and better way of working with Docker. So let me go ahead and pretty much show you exactly how it works, or actually how it's downloaded. So you can see that they have a screenshot. So basically, once you have an account, then you'll be able to download Docker. So basically, you take this docker.app, put it into your applications, and then you'll see that you have Docker. And then at the very top on your toolbar, you can see that you'll get a Docker logo. So this logo right here, and you can see that it will say Docker is up and running. And you can see right here in my machine, because I already have Docker installed, you can see that Docker is up and running. So it's very straightforward to get started with Docker. So for Windows, it's pretty much the same thing. So what I'm going to do is collapse this, click on Windows, install Docker on Windows, and you can see that it's the exact same thing. So download from Docker Hub, there we go, it's the exact same thing. So please log into download, and then once you have it downloaded, you can follow these instructions right here. But basically, it's the exact same thing here. So if I scroll down, you can see that you have Docker for Windows. You will also get the actual Docker logo, and then you'll see that Docker is now up and running, which is the exact same thing that I have here. All right, now that we have Docker installed, go ahead and click on this Docker logo icon at the very top, and you can see that we have a couple of options right here. So we have preferences, updates, documentation, more of Docker, sign in, and Kubernetes. So what I want you to do first is to open up your terminal or command line and simply type Docker. And you should see that you get a bunch of commands. So you can see that you get a bunch of stuff really. So options and then management commands. And you can see all of these commands that we will learn in this course. So you saw that you can type Docker, but also if I go ahead and type Docker -- and then version, you can see that this is the version of Docker that I have installed on my machine. This might be a bit different for you, but the commands will be the exact same thing. So what I want you to bear in mind is that if I click on the Docker logo again, and then quit Docker desktop, and then type Docker, and for now, simply go ahead and type Docker PS. You can see that cannot connect to Docker daemon right here. So the Docker daemon is not running. So whenever you are using Docker, make sure that the actual Docker daemon is running. So let me go ahead and simply run it again. And let me skip this version. and you can see that it's starting. Just give it a second. You can see that it's starting right here, and there we go. You can see that it's green. If I now go back to terminal and type docker ps, you can see that this time it works, right? So just to bear in mind that whenever you want to use Docker, you have to make sure that the Docker daemon is running. And there we go. You now have successfully installed Docker and know how to get it up and running. Let's begin our journey in learning Docker. Let's begin our journey learning this awesome technology called Docker. All right, let's go ahead and learn about Docker images and containers. So an image is a template for creating an environment of your choice. This could be a database, a web application, an app that does some processing. Pretty much it could be anything. An image is also a snapshot, and you'll learn more about this. But basically, you can create multiple snapshots, i.e. versions of your image, and then you can point to whatever version that you want at a particular time. So let's say that you deploy to production an image, you find out an error, and what you can do is simply go back to the previous image. What is so special about an image is that it contains everything your app needs to run. It contains the operating system, any software required, as well as the application code. So once you have an image, then containers come into play. So a container is simply a running instance of an image. So what you do first is you have an image, and then from that image, you simply run a container. Let's go ahead and download an existing image and run a container from it. So navigate to hub.docker.com, and right here you can see a list of all public images. So right here, so you can see that if I scroll down, you have a list of official images. So these are companies, for example, such as Nginx, Mongo, Node, Redis, Ubuntu, Couchbase, Golang. So there are tons of these official images that we can use, but also there are some unofficial images. So these would be, for example, someone like yourself or I that don't necessarily own a large company, but we just build images for other developers to use. So we could also distribute these images inside of this Docker registry. So Docker Hub is simply a registry, and we're going to learn more about registries later on, but a registry is simply a place where you can download images. So you can see that I can explore some images. So let me go ahead and simply explore, and you can see that there are tons of these images, right? So I can scroll down, and the list is endless. So the one that I want to try out with you is this one, Nginx. So what I'm going to do is, if you don't see this image right here, so Nginx, so scroll up, and right here simply type Nginx. So I always get this wrong. So Nginx, just like that. So I always get this name wrong. So Nginx is simply a web server, a reverse proxy, a load balancer, and it's very popular and it's used all over the internet. So if I scroll down, you can see that they have some tags, and we're going to learn about tags later on. Dockerfile as well. Later on, we will learn about this. And they have some quick reference. So what is Nginx and how to use this image. So let's actually scroll up, and you can see that they have this command right here. So docker pull and then Nginx. And let's go ahead and pull this image. So let me go ahead and open up terminal, or you can use command line if you are on Windows. So let's simply go ahead and say docker and then pull and then ng and then x, just like that, and then press enter. and you can see that it's using a default tag, and it's actually downloading Nginx for us. So just give it a second, and I'm going to explain all of this later on. But basically, if this image changes, it doesn't have to download every single layer again, so it is cached. There we go, and you can see that it has downloaded a newer image for Nginx and then column latest. So this part right here is the actual tag, and we're going to learn about tags later on. But basically, this is simply getting the latest image. Now, in order for us to see a list of images that we have locally, simply go ahead and type docker and then images. And there we go. So you can see that the image that we have currently is this one. So we only have one image, and the name is Nginx. The tag is latest. This is the image ID, and you can see that it was created about 3 days ago, and the size is 109 megabytes. There we go. You successfully managed to pull your very first Docker image. Next, let's go ahead and run a container from this image. Alright, let's go ahead and run a container from this image that we've just downloaded. So Nginx, and then the tag is latest. So remember, a container is a running instance of an image. So to run a container from an image, simply type docker and then run, and then we have to specify the actual image. So in our case will be Nginx, and then you have to specify the tag. So in our case, latest. So if I press enter, you can see that we get nothing. So believe me or not, but we are actually running a container. So the reason why this is hanging, because the process has started and is just waiting. So what I'm going to do is open up a new tab, and inside of this tab, what I'm going to do is first, let me actually make this bigger, and so something like that, so you can see exactly what we're doing. So what I'm going to do now is describe the list of all running containers. To do that, simply type docker and then container and then ls. Press enter. You can see that we have this container with an ID of 83910ABD360C, and then the image is Nginx latest. You can see some commands created about a minute ago. The status is up about a minute, and you can see that the ports, it's 80. So 80, I'm going to explain the port in a second. And the name is Happy Volhard. So I'm going to explain this bit in a second. So this port right here, because it's very important for us. But you can see that we have an image up and running. So go back to the other tab, and you can see that right here. So this is actually a bit bigger now, but basically the process is hanging right here. So what I'm going to do is simply cancel out of this. So Control C. There we go. I'm going to clear the screen there, and right here simply type docker container and then ls, and you can see that the container is no longer up and running. So the same here. So remember, this was a container, so docker container ls. You can see that nothing is up and running. So what I'm going to do now is close this tab, and I'm going to run the container. So docker run Nginx latest. But now what I'm going to do is add a flag. So minus and then D. So this simply says run this container in detached mode. So if I press enter, you can see that the process is no longer hanging. So it's running in detached mode. And then we get this ID right here. So now we can view the list of all containers running. So docker and then container and then ls. Enter. you can see that this is our container, which is up and running 18 seconds ago. So let me go ahead and clear the screen. Another way that you can check the list of running containers is simply type docker and then ps. So this is the preferred way and much faster. Enter, and you can see that we get the same thing. And now you can see everything is the same apart from the actual name right here. So suspicious Snyder, and the port is the same. So this port right here I'm going to explain next, but this is very important for us to understand. So 80 and then TCP. And there we go. So you successfully managed to run your very first container by running docker run -d in detached mode, and then the name of the actual container. So nginx and then a latest. Next, let's go ahead and learn exactly how we're going to be able to use the container. Let's go ahead and learn about how to expose ports with Docker. So far we have our host, which has Docker running. So we are running Docker in our computer. And right now we have one single container, which is running nginx. And this container is exposing a TCP port, and the port is 80. So let me show you exactly this again. So right here, you can see that we have ports and then 80 and then /TCP. So what we want to be able to do is from the host, we want to issue a request to our container, which is exposing port 80. So we want to be able to go to our web browser, type localhost 8080, and then that port 8080 should be mapped to port 80 on the container. So basically we want to go from the host to the container. And the way that we achieve this is simply by adding -p before we run the container. So -p 8080 from the host should be mapped on port 80 on the container. And then we'll be able to access the application running from within the container. So let's go ahead and open up terminal or command line. And what I'm going to do first is stop this container. So to stop a container, simply type docker and then stop and then pass the container ID. So I'm going to command C that, command V, and then enter. And you can see that the container has stopped. So if I type docker ps, you can see that nothing is running. Let me clear the screen. So I'm going to issue the same command. So docker run -d or -d. And then let's go ahead and say dash and then p. And we want to go from the host. So whenever we type localhost 8080, we want that to be mapped to port 80 on the container. So press enter, and you can see that the container is up and running, docker ps, and there we go. So now you can see that the ports is a bit different. So you can see that right here, we are simply saying map localhost 8080 to port 80 inside of the container. Now let's go ahead and open up any web browser and then simply type localhost and then column 8080 and then enter. And there we go. So you can see that we have this welcome page that says welcome to nginx. And there we go. So we've managed to map the host port 8080 to the container port 80. So let me go ahead and pretty much just stop this container. So docker and then stop and then pretty much just get the ID. There we go. If I now refresh, you can see that the site can't be reached. So we've mapped port 8080, but you could also map a different port. So let's go ahead and map port 3000. There we go. Now if I change this to port 3000, and you can see that it's working, but from a different port. We could also map both port 8080 and port 3000 to port 80 inside of the container. So let's go ahead and do that. So let me go ahead and simply stop the container. So I think this will be now a different container. So let me go ahead and simply say docker and then ps, grab the ID, docker stop. There we go. Clear the screen, Control L. Now if you want to map more than one port, simply add another -p 8080 to port 80. Enter. Now if I type docker ps, you can see that right here localhost 3000 maps to port 80 inside of the container, and localhost 8080 also maps to port 80 inside of the container. So let's go ahead and test this out. So if I refresh, this should work. So 3000 works, and now 8080, and this also works. There we go. You now know how to map ports from the host to containers. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let's go ahead and learn exactly how to stop, remove, start, and name containers. So if I go ahead and type docker ps, you can see that currently we have this container right here. So this is the ID, and it's mapping both port 3000 and 8080 to 80 inside of the container. So this is what we have currently, right? So this is the Nginx localhost 8080. This works, and localhost 3000. This works. So the way that you stop containers is simply by saying docker and then stop, and then you can pass the ID or the actual name. So let's go ahead and grab this name right here. So Command C, paste that in, and then enter, and you can see that we get the name back. Now if I check my web browser, refresh, you can see that it's not working because we stopped the container. Now an interesting thing is we've just stopped the container, but we haven't removed it. So the container is still available for us to start. So to start the container, simply grab the same name and say docker start, and then the same name or the actual container ID. Enter. You can see that I get the name back. If I check my web browser, and there we go. So you can see that the page is working again. Now let me go ahead and stop this container. So it's docker stop, and this time I pass the actual ID, and let me clear the screen for now. Refresh the web browser, you can see that it's not working. If I go back, so how do you know the list of containers that are not running? So if I type docker ps, you can see that we have no containers right here. But indeed, what this command does, so docker ps, it simply lists the running containers. So go ahead and type docker and then ps --help. And right here you can see that you can pass some options. So -a for all, and you can see that the default shows just running, and you can do some filtering. You can do quiet, that displays only the numeric IDs, and you can check the size as well. So let me go ahead and simply clear the screen and type docker ps - and then a. And you can see that we have a couple of containers right here, and all of them are Nginx. So remember, up to now, we've actually stopped many containers and then we start them again. And whenever we start them, we simply got a different name. So you can see that this is a different name. This is a different name. The same here. And also the ID, right? We get a brand new container. So we've never reused existing containers. Now, how do we delete containers, right? So how do we delete containers? So to delete a container, so what you need to do is simply say docker and then rm, and now you can delete a container by the actual name or container ID. So let's grab this very first one right here, created 25 minutes ago, and you can see the name is Elastic Sanderson. Paste that in, enter, we get the actual container back. Now if I type docker and then ps -a, you can see that the container is gone. So if I remove that, and remember, I've actually searched before, so this is the actual ID that we removed, and you can see that it's no longer in this list. So just let me cancel out of that. You could also remove every single container in one single command. So you could say docker rm, and then you could say I want to delete that one, and then you'd say I want to delete this one as well, so docker rm. But you can see that it's a bit tedious. So what we can do is grab every single ID and then pass that into a command, and then we will delete everything. So the way we do it is simply, so if I clear the screen, so docker ps --help, you can see that we have this quiet, so display only numeric IDs. So let's go ahead and say docker ps - and then a, meaning that I want every single container, including the ones which are stopped, and then q for quiet, that gives me only the numeric IDs. If I press enter, you can see that I've got only 5. So if I want to remove all of these, I simply type docker and then rm, and then press $, and within $, simply say docker ps -a and then q, right? So we're simply getting this command and passing it inside here, and this will remove every single container that we have. Now bear in mind that if you have a container that is running, this won't work. So let me first delete, and then you'll see it. So if I remove everything, you can see that I get every single ID back. Now if I type docker ps -a, you can see that we have no containers available. Now let me go ahead and start a container. So if I clear the screen, so let me search here, so 3000, and let me go ahead and start this container. There we go, docker ps, you can see that it's running. If I refresh the browser, there we go. Now if I go ahead and simply try and remove the container, right? So let's go ahead and run this exact same command, so docker rm, and then give me all the containers. So if I press enter, it says that you cannot remove a running container. Stop the container before attempting removal, or you can do a force rm. So the way that force rm works, so you simply pass -f, and it simply says that I really don't care whether it's running, I simply want to remove the container, and that's it. So if I press enter, you can see that that took a while, and I get the ID back. So if I refresh the page, you can see that we have no containers. Now if I do a docker ps, and there we go, docker ps -a, enter, and we have no containers available. If you have any questions on stopping, starting, and removing containers, go ahead and drop me a message. Next, let's go ahead and learn how to name containers. All right, let's go ahead and start a container. So simply type docker run -d -p and then expose whatever ports that you want and then press enter. So if I type docker ps, you can see that we have a name right here. So elegant and then ride. So usually this is a random name that is given to you if you don't specify a name. But in reality, when you create your own containers, you should be giving them a name so that you don't rely on the ID nor the actual random name, right? So the way that you give a name to a container is simply by using -- and then name. So let's go ahead and simply stop this container. So docker, actually, let's go ahead and force remove everything. So docker rm -f docker ps and then -aq, enter. There we go. So now let's go ahead and run the exact same command. So docker run -d. So what I'm going to do is go to the start and then right here, simply go ahead and type -- and then name. And now we can give this a name. So let's go ahead and simply say that this will be our website, right? So now if I press enter, you can see that the container is running. But if we type docker ps, you can see that now the name is website. And this makes your life much easier for you to identify your containers. And trust me, you should always name your containers because most likely you'll be running multiple containers at the same time. So now I can simply go ahead and say docker stop and then website. And you can see that I don't have to rely on the actual container ID. I could use it, but because I've named my container, I can simply say stop my website, just like that. So if I press enter, you can see that stopped the website and I can simply start it again. So docker start and then website. So there we go. You now know how to name containers. All right, let's go ahead and learn exactly how we're going to take docker ps and format this result right here. So you can see that sometimes it might be a bit difficult for you to read what's going on. So you can see that we have container ID and then the ID it's right here. And then we have the status and the status goes over to the next line. And then we have the image and you can see that the ports, then it's, yeah, sometimes it's very difficult for you to read. Let's actually go ahead and start a second container. So docker and then run and then -d -p and then nginx and then latest. And let me actually name this. So -- name and then website and then 2 and the port as well. So let's go ahead and simply map 9000 to port 80. So press enter. You can see that it's running. So if I do a docker ps now, you can see that I've got 2 containers up and running, and the output is it's even harder to read actually. So what we can do is simply use a format. So we can say docker ps and then minus format, and this is equal to, and what I'm going to do is simply copy some code right here, but basically this simply gives a label and then tab, and then right here it grabs the actual ID. The same with name and then names, image and then image, port, so on and so forth. And you can get this entire line in the description of this video. So let me go ahead and simply Command C, go back, and what I'm going to do is simply paste that in, and this has to be within quotes. And if I now press enter, you can see that now the format is much nicer. So you can see that we have the ID, the name, image, port, command created, status. And basically it's much easier for you to read if you don't have enough room. So what I like to do with this is simply export to a variable. So format equals to, and then paste that again. Oh, actually, I need to paste this again. So copy and then paste that, enter. And now if I type docker ps, you can see that it's not formatted. And if I type docker ps dash dash and then format equals to $sign and then format. So this is the name of the variable. So this $sign format refers to this variable right here. So if I press enter, and let me do that again so you can see exactly nice and neat. And there we go. So you can see that it's formatted. And there we go. You now know how to format the results of docker ps. All right, in this section, let's go ahead and learn about Docker volumes. So Docker volumes allows us to share data. This could be files or folders. So you can see on the diagram that I have here that you have a container, and then you have the file system, and under that you have the Docker area. And through the container and the file system, you create a volume. So I'm going to show you exactly this in a second, how it works. But volume simply allows us to share data between host and container, and also between containers. So the way it works is that you have a container running on a host. And in our case, we have an Nginx container. So one, we have to create the volume, and then this volume allows you to share data between the host and container, and vice versa. So let's say that we add a file in our host, in our machine. This file A will also appear in the actual container inside of the volume. The same by adding a file in the actual volume inside of the container, that will also appear in my host operating system. And the same is true with folders. So if you add a folder on your host, then that will also appear in the actual container. Let's go ahead and learn exactly how to share data between host and container. All right, so go ahead and navigate to help.docker.com and search for Nginx. And right here, what I want to show you is exactly how we're going to be able to serve our own files during development with Nginx. So scroll down, and right here you can see that hosting some simple static content. And basically you can see that right here. So they give a name to this container, so some Nginx, and then -v, and then this is the actual volume. So this bit right here is the source, and this is the destination. So inside of the container, so this path right here, so user share Nginx and then HTML, inside of that folder we can share our own files. And if you are developing an application or a website, that's where you should put your files in. And then right here you can see that this is a read-only volume. So let's go ahead and pretty much create a file and then mount our directory inside of this folder so that we can override the default Nginx welcome page. So let me go ahead and open up terminal and docker run and then -- name. Let's go ahead and create a website. So I've deleted all the previous containers, and -p and then 8080 to 80, and then the actual container will be ng and then next, and I can say .latest, or if I don't specify the actual tag, it will bring the latest by default. So if I run this, or actually let me actually add -d for detached, and then if I go to my web browser, refresh, You can see that's forbidden, and this is because this is 8080. And there we go. We have this default Nginx welcome page. In the next video, let's go ahead and override this default web page by simply mounting a volume from the host to the container. Alright, let's go ahead and create a volume between our host and our container. So inside of our desktop, so in the host machine, we will create a folder called website, and then we're going to have an index.html. So that file, or the contents inside of the website folder, will be shared inside of the container in the following directory. So users, share, nginx, and then HTML. So that way, when we hit the URL in our web browser, we will be served with our own files. So let's go ahead and do that now. So right here, what I'm going to do is pretty much just open up VS Code and go ahead and open up your favorite IDE. But in my case, I'm going to open up VS Code. And then what I'm going to do is simply create a new file. And then in this file, let's simply go ahead and have an h1. So this will be some HTML. So h1, and then hello, docker, and volumes. So we will have a better page, but for now, this will be enough. So now go ahead and save this. Navigate to desktop. Inside, create a new folder. Name this as website. And then create. And then name this as index.html. Press enter. And there we go. Now what I'm going to do is start a container and mount the website folder to our container. So go ahead and open up terminal. And right here, let me simply say docker and then stop and then website. There we go, docker rm and then web and then site. There we go. So this is completely removed. So now let's go ahead and navigate to the website folder. So cd and then desktop. And there we go. And also cd into website. So if I do an ls, you can see that we have index.html. Now let's go ahead and start a container and then mount the entire folder to our container. So the way we do it is, let's go ahead and scroll up, or actually go up a couple of times. And now what we're going to do is, so pretty much after website, so after you name the container, go ahead and simply say dash and then v. And then right here, we can simply say $, and then within brackets, pwd. So this simply takes the present working directory. So let me actually show you. So let me cancel out of that. If I type pwd, I get the content. So this is what I get, right? So if I pass that. So I think on Windows, you simply say dir and you get the same thing. So let's go ahead and grab this again. And then what we're going to do is we're going to mount this folder called website to, and remember, so if I open up Nginx, you can see that this is the actual destination. So user, share, Nginx, HTML, and then you can say read only. So grab everything and then go back and then paste that in. And there we go. So now let's go ahead and press enter. And there we go. You can see that we have started a container. And if I now go to my web browser, and then remember before we had this welcome page, which was the default presented by Nginx. Now if I refresh, you can see that we are serving our index.html. So let's go ahead and change that. So let me go ahead and simply say hello with volumes, and then let's simply say read and then only. Save this, go back, refresh, and you can see that the contents are mounted, right? So whenever we change the index.html, that is reflected in our container. So what I'm going to do now is I want to show you that if we have a file inside of the container, that will also appear in our host. So go ahead and simply type this docker and then exec and then -it and then simply say website and then bash. So this simply says that we want to execute this in interactive mode, pass the actual container, and then we want to execute the bash command. So if I press enter, you can see that now we are inside of the container. So if I type ls-al, you can see that this is the Linux file structure inside of our container. So remember, this is the running container. So now remember, we mounted user share nginx HTML. So let's go ahead and navigate to that. So cd and then user share nginx HTML. And then if I clear the screen, if I do an LA or actually ls-al, you can see that we have our index.html. Now let's go ahead and simply say touch and then about.html. And this is just a file with nothing inside. So if I press enter, you can see that this is a read-only volume, which means that the container can only read the contents. If it wants to add, if it wants to write to it, it's impossible. So the way that you tackle that, so let's go ahead and exit this container. So Control and then D and then docker ps. Let's go ahead and simply say docker rm-f and then website. There we go. Now what I'm going to do is simply run the exact same container, but right here, instead of passing the read-only flag, I'm going to remove that. Enter. Now let's go ahead and bash into the container again. So docker exec -it website and then bash. Enter. cd to user and then share nginx HTML. If I clear the screen, now if I do an ls, you can see that we have index.html. If I touch about.html, press enter, you can see that works. Now if I go to my desktop, and you can see that we have this folder right here called website. So I'm going to open it up, and you can see that we have the about.html right here. So from our container, this file also appears in our host, and you can see that this still works. And there we go. This is how you share files between the host and containers using volumes. All right, let's go ahead and customize our website. So this website right here, which simply says hello docker and volumes. And by the way, that's not read only anymore. So let me go ahead and remove that. And if I visit the page again, refresh, you can see that hello docker and volumes. So go ahead and navigate to Google and do a search on Bootstrap single page template. So go ahead and click on this very first link. So free Bootstrap 4 landing page themes. And right here, go ahead and pick any website of your choice. So what I'm going to do is pretty much just pick this one right here. So grayscale, and then click on view on GitHub. There we go. So now let's go ahead and simply clone or download. Let's go ahead and download the zip. Now open this in your desktop, and then let me unzip this. There we go. Delete the zip. And what I'm going to do is pretty much just take everything. So I'm going to take everything here, Command C, and then go to my website, and then let's delete everything and then paste. There we go. So you can see that we have this index.html, and we can go ahead and delete this folder. So bootstrap grayscale master, delete that, and there we go. So now I'm inside of the container, so I'm going to do an ls -al. You can see that we have the files that we've just downloaded. So what I'm going to do now is simply visit the web page. So I'm going to close this and this as well, and go ahead to localhost 8080. Before we had hello docker and volumes. Now if I refresh, you can see that we have this awesome website. And feel free to make changes to this website according to your needs. So you can see that this works beautifully, right? So you can see that we have a nice, beautiful website. So I can click on projects. You can see that takes me to projects, contact, and there we go, right? So let me go in about, and you can see that it's built with Bootstrap, and you can see that it's working beautifully. And there we go. I just wanted to show you that you don't have to have a boring website as we had. So you can go ahead and build your own website and then deploy it with Nginx. Alright, now let's go ahead and learn how to share volumes between containers. So we have a container A and we have a container B, and we can share a volume between them, i.e. we can share the contents of a folder or a file between these two containers. So let's go ahead and try that out. So currently we have this Nginx container named website, and it's serving our beautiful website. So you can see that running on localhost 8080. The way that we can share files or folders between containers is by using a command volumes from. So go ahead and type docker run --help, and this will give you all the options that you can use with docker run. Enter, and you can see that at the very bottom you have volumes from. So -- volumes from, and then mount volumes from the specified container. So let's go ahead and clear this, and then docker ps. So let's go ahead and start a brand new container. So docker run, and then --name. Let's go ahead and call website -copy, and then and then d minus and then p. So this will be 8081 to 80. So port 80 is already being used, so we have to map to a different port, and then go ahead and simply say ng and then next. And right here what we need to do is simply say volumes, right? Because we want to map a volume from this running container. So the way you do it is --volumes and then from, and then you pass the actual name. So the name of the container is website. Now let's go ahead and press enter, and you can see that it's up and running. Docker, or actually let me press up 2 times, clear the screen. You can see that we have 2 containers running. One container is available through 8081, so that's the port, and this is the website copy, and the website is through our 8080 port. So let's go ahead and give that a go. So open up your web browser. So 8080, so this is the main website. So refresh, you can see that this still works. Now if I go ahead and hit the 8081, which is the website copy container, and we shared all the contents from the website container to the website copy container, this container should have the exact same website. So if I press enter, you can see that still works. So we've managed to share data across these 2 containers. All right, and this is it. So as you saw, Docker is very powerful, and to be honest, it is the standards today. So I highly recommend you learn about Docker. You can get the full course in my website, which I'm going to leave a link down below, Also, if you haven't subscribed to my channel, go ahead and subscribe to my channel to get more videos like this. Give me a thumbs up, and until then, I'll catch you on the next one. See ya.